Our team is working on an affordable weather monitoring system. Imagine a community where farmers must make critical decisions without knowing if a storm is coming or if their crops will even survive the season. Reliable weather data could transform daily lives, protect livelihoods, and build resilience, but right now it's out of reach for many. Our solution empowers communities with actionable environmental information, creating opportunities, safety, and sustainability. Current weather monitoring systems are highly sophisticated and costly, making them inaccessible in developing regions. Therefore, this project aims to design an autonomous, cost-effective weather monitoring station for under $500 for use in southern Madagascar. It will provide critical environmental data and establish a replicable model that can be adapted in other resource-limited regions, bridging the gap between advanced monitoring technologies and the communities that need them most.
Our team's approach centers on creating an affordable, replicable weather monitoring station optimized for Madagascar's resource-limited communities. The design integrates low-cost sensors to measure temperature, humidity, wind, solar radiation, and precipitation, all powered by a solar panel system that enables remote placement and reduces maintenance needs. An ESP32 microcontroller manages data processing and long-range connectivity through Wi-Fi and Bluetooth, expanding access to communities that currently lack reliable weather information. By using easily sourced components, simplifying fabrication, and addressing the stakeholders' priorities of functionality, affordability, and portability, the system provides a scalable alternative to Madagascar's current systems in place. This improved data access will also serve as an early warning system, helping communities better prepare for extreme weather events. A clear process flow from environmental inputs to data analysis ensures consistent, actionable insights while demonstrating a model that can be easily replicated.
Our project has an excellent benefit to cost relationship. The upfront costs required for the design, development, and implementation are meaningful investments, but they are far outweighed by the long-term gain in efficiency and overall improved user interaction. The upfront cost for this system includes the sensors, base materials, testing, and installation. However, the measurable benefits of reduced labor demands and maintenance, while increasing storage life and user experience, will ultimately be far more significant than the initial investment. Current monitoring systems can cost up to tens of thousands of dollars, with varying lifespan with potential manual on-site data collection. Our approach integrates low-cost sensors, renewable energy power systems, and data storage solutions to achieve functionality comparable to those high-end systems at just a fraction of the cost. Looking at the operational lifespan, the overall gains of the system will justify the initial investment for our product.
When looking at existing solutions, we found that most weather monitoring systems are either too expensive or not built for the conditions that we're targeting. Commercial systems, like those from well-known competitors, are very accurate, but they can cost anywhere from $2,000 to $10,000 per unit. That's simply not feasible for widespread use in developing regions. Government and NGO stations do exist, but they tend to have limited coverage, require technical maintenance, and often rely on stable power sources that aren't always available. On the other end, there are low-cost DIY systems based on Arduino or similar platforms. They're affordable, but they typically lack durability, accuracy, and weatherproofing needed for long-term operation in these environments. Our design bridges that gap. It's affordable, self-powered, and built for remote, resource-limited environments, offering a sustainable and scalable solution for vulnerable communities. Looking ahead, our next step is to move from design to a working prototype and begin testing its reliability in real conditions. We're aiming to redefine the system's sensors, ensure it stays low cost, as well as being easy to maintain. Support from faculty, partners, or anyone with experience in sensor calibration or field testing would position our project as one to be able to make it to the next stage. Our goal is simple: build a weather station that truly works for the communities that need it most. Thank you.